integrate this rational function here. We've got 3x plus 5 over x squared minus 4x plus 3. Now, there can be many approaches depending on what rational function you've got, but if you just want to sort of put your head down and do some calculations, something that always works, if you see a rational function, you think partial fractions. Okay. So partial fractions decomposition, what's the process? You want to factor the denominator, so that's the first thing you do, and you assess from there. Now, if we factor our denominator here, x squared minus 4x plus 3, we get x minus 3, x minus 1. Depending on what you see, your decomposition, your partial fraction decomposition might look a little different. For this one, we have sort of the most plain and simple case. We've got distinct linear factors. So you factor the denominator. Sometimes you get the denominator already factored when it's given to you, and then you set up an appropriate partial fractions decomposition. So when you have distinct linear factors, I'm going to rewrite the denominator in its factored form here, just to help me remember. When you have distinct linear factors, each factor goes on the denominator of its own separate fraction. And then because they're linear, we get a nice single constant a and b. So this equation will hold. The left-hand side and the right-hand side will both be equal, where they're both defined, for a unique pair of a and b constants. Our goal now is find a and b. Okay? And there can be lots of ways to do them. Most involve algebra, linear algebra in particular. But I find it's probably easiest if you just come along and you multiply both sides by whatever the denominator is here. So you multiply everything by the x minus, and this is why I have it factored, the x minus 3, x minus 1, because, well, those will completely cancel. You'll be left with 3x plus 5 here is equal to a times x minus 1 here plus b times x minus 3 here. So because this has to hold for a and b, this statement now holds for a and b. And what we can do is we can come along and we say, well, x minus 1 has a root of 1. So if we let x be 1, the left-hand side and the right-hand side, they still have to be equal. 3 times 1 plus 5 is 8. And you get a times 1 minus 1, which would be 0, plus b times 1 minus 3. You'll get negative 2b. So b is going to have to be negative 4. So then we can solve, okay, b will have to be negative 4 in order for this to work. And we can do the same sort of trick. Let's let x be 3, so that 3 minus 3 is 0, and we basically ignore the b factor. But you'll still have left-hand side is equal to right-hand side, so 3 times 3 plus 5, 14. A times 3 minus 1 is 2, plus b times 0. So 14 is going to be equal to 2a. A would have to be 7. Okay? So our partial fraction decomposition, so we say something like, we can decompose 3x plus 5. Oh, we don't need the integral yet. I'm getting ahead of myself. We'll integrate in a second, but it's always good once you've got your a's and your b's and you see all your constants, it's good to summarize and say, here is my partial fraction decomposition in all its glory. Get everything out in the open, get it straight. So we get 7 over x minus 3 minus 4 over x minus 1. Right? Left-hand side is equal to right-hand side where they're defined. And this allows us to integrate. And we do this by making a little switch. Right? This is what we want to integrate over here on the left. 3x plus 5 over x squared minus 4x plus 3. But we can break that down into, well, just rewrite the integrand as 7 over x minus 3 minus 4 over x minus 1. And split this up into a difference of integrals. And in fact, while we're at it, we can even bring out the factors of 7 and 4. So 7 times the integral of 1 over x minus 3 minus 4 times the integral of 1 over x minus 1. And the point of the partial fractions decomposition is this rewrite. Trade the integral that we have trouble with for two smaller simple integrals. That, if you really do a lot of these partial fractions, you might know in general that 1 over ax plus b integrates to 1 over a ln ax plus b, plus a constant. Okay? So if you know them a lot, you can use sort of that building block to help you out. Or you can just, these are a lot easier, you can just do sort of substitutions. Let u be x minus 3, let u be x minus 1. That's fine as well. But either way, we go ahead and integrate. So we'll get 7 ln x minus 3 minus 4 ln x minus 1. And we're done, and it's an indefinite integral, so we tack on the plus c. And we're happy. There we go. There's our final answer. 7 ln absolute value x minus 3 minus 4 ln absolute value x minus 2 plus a constant. And we're good to move on.